All right, here's the one I've been looking for. We're in Savas Algebra 2, Lesson 7-1, Trigonometry. And what we finally have got here is a little review set of problems, though, that aren't really trigonometry, but exponents and how do you solve some of these exponent properties. We're talking about a little bit, I'm thinking we've got growth and decay, and we're solving for an exponent. I think that means we're going to have to use a little logarithm here somewhere along the way. Let's jump into it and take a look. Hopefully this will be a little refresher for you. I know most students in Algebra 2, one of the first times, if ever, not the first time that you started looking at logarithms. But let's see. Determine whether the function represents exponential growth or decay. So first of all, whenever the space right here, that's what you're going to be multiplying every time because that's what an exponent is, right? Repeated multiplications of that number. And if it's over 1, it's going to be growth. So we should be able to, right here. So it is growth. And then it says, write the base in terms of a rate of growth or decay. So over there, when it says that, what that's getting at is write this base in here. So it's 1 plus the amount of growth here. And the amount of growth to get a 3.6 would be 2.6. And I think that's what they want in there. And then my rate here indicates the value of y is increasing. So is the 2.6. And then that means the value of y is increasing. And the percent here, if we're talking about 2.6, that's 260%. It's multiplying it by 100, so you need decimal over 2 places if you're making it into a percent. Let's see if those are all the answers that they were looking for. I believe that's what it is. Sometimes Savas wants it written a little bit different and expects some things slightly different, but there's my 1. That means I keep the original, the 1, and then I'm adding on 2.6 more to it. And then this 2.6 is just the amount I'm adding, and then increasing, and then this rate right here that I'm adding could be the 260%, but usually I believe they just want the R, the 2. And then what is 2.6 in decimal? If it's added right here, that's 260%. So let's see if those everything. That's everything at once. We've seen some of those before. You may have forgotten, but that's the way those are structured. And hopefully that gives you a little help. If you're looking for some of these might be hard to find one that's going to have a resource structured exactly the way Savas wants it, but you can do exponential growth and exponential decay. They were solving for that x and giving you an answer they wanted. That's where you would have needed to use your logarithm that I mentioned at the beginning of this problem when I was looking at it. So hopefully that helps. You've got this, you can get it. If not, bring me your questions. I'll be happy to help. And I know you can do it. Just don't give up. You got this.